All right. Hello, everyone. So today I'm going to run through the second part of the notes of significant figures for Unit 5, the counting and calculations. I'm going to do the counting and calculations part. Or I'm sorry, I'm going to do the calculations part. So significant figures and calculations. There are two different rules uh, that we use for figuring out how many significant figures our answer needs when we do math in science. So the first rule is the rule that applies to adding and subtracting. Okay, and then on the back, the second rule is the rule that applies to multiplying and dividing. Right, so the adding and subtracting rule. Now, as I told the people in class, I kind of apologize in advance. The way this is worded can be confusing. I've been teaching this for almost 20 years, and I just can't find a better way to word it. Can be a little difficult concept. I will try to make it as easy as possible and explain through it. And usually the easiest way to kind of do that is just for me to do the examples as I go through it. Okay. So if we've got math problems that are adding, subtracting, now the first thing we're going to do is we're going to assume that all of these numbers that I give in here are inexact numbers or measurements, because those are the things that we do significant figures for. Okay, versus exact numbers, which we don't. So first thing, add or subtract, do the math. So for number one, I'm going to do 8.711 minus 4.79. And I get, I'm going to line this up vertically. I'll explain why in a second here, you'll see. Minus 4.79. And the answer we get is 3.921. Okay. Excuse me. So what we need to do is we need to figure out where we need to round our number to have the right number of significant figures based on our adding and subtracting rule. So find the estimated or the furthest right significant figure for each measurement or inexact number in the problem. So remember I said we're treating all of these numbers as measurements. So we need to find what's called the estimated or the furthest right significant figure. So significant figure furthest to the right of 8.711 is the 1. For 4.79 is the 9. Okay. Then round your answer to the least specific, or in other words, furthest left placeholder of the estimated digits spots. So this is why I did it vertically. Like if you think of the digits, the numbers, as being in certain spots like ones, tenths, hundredths, thousandths, like that, like think vertical column wise like this. Okay. Of the estimated digits, the ones that I circled, which one is the furthest left? Well, that would be the 9. What that tells you is that is the decimal spot that you are going to round your answer to. So this is in the, what is that, hundredths? That's the hundredths. So that means we're going to round to this spot. Now it's normal math rounding. Okay, you don't do anything different. So if this number is 4 or less, you leave it the same. If the number after it is 5 or above, you round it up. So the 1 does not round the 2 up. So this becomes 3.92 is the correct answer. Okay. All right. I'm going to go to number 3 first because 3 has something that I want to show you guys, and then we'll work on these. So in number 3, there's both subtracting and adding. You can do it all at one time and round at the end because the rule for adding and subtracting is the same. Okay, so I'm going to do the math. I'm going to actually line this up horizontally again, or I'm sorry, not horizontally, vertically. So 3, 2. And the reason I was lining it up vertically is so I could tell them like what decimal spots to like compare them. Minus 167.3 plus 25.047. Okay, I'm going to do the math. So 3280 minus 167.3 plus 25.047 gives us 3,137.747. Okay, now we need to figure out where we're going to round our answer to. So again, the significant figure that's estimated furthest to the right for each number. So this one, 3,280, remember, no decimal, so we count from the right. We would not count the first zero. We would not count the zero because we haven't hit a non-zero number. So we would start counting at the 8. So the 8, the 2, and the 3. So there's 3 significant figures, which means the one furthest to the right would be the 8. Okay. 167.3, all significant, so the 3. 25.047, all significant, so the one furthest right is the 7. Okay, again, of those, we are comparing like decimal spot wise, which one of those is furthest to the left? That would be the 8. So that's the spot we're going to round our answer to here. If you look here, does that round it up? Yes, it does. So this becomes 3, 1, the 7 rounds to get to a 4, 3,140, 0, no decimal point. Now, sometimes people get kind of like caught up in thinking, oh, it's significant figures, it's different, blah, 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 whatever. Yeah, the significant figure part is, but the rounding is just normal math rounding. So if I gave you like 3,137.747 and told you to round it to the 10 spot, you wouldn't get like 314 because that's a different number actually. We just want to round this number. So we're rounding it to here. So 3,140, you got to add the 0 till where the decimal would be. So that's the answer. All right. Let's take a look at number 2. So there's a little trick you can use because obviously, as I said, this is sort of complicated for the adding and subtracting rule. It can be a little difficult. There is a little bit of a shortcut we can use, but it's only in certain cases, right? So if all of your numbers have decimals, like a decimal portion, if all the numbers have a decimal portion, then you can do this little trick. If some of the numbers do not, like in number 3, this did not have a decimal portion, so you can't use this trick that I'm going to show you on this one. Okay, but here, all of them have decimal portions. So what you can do is first do the math. So 58.699 plus 2.4291 plus 5.79. Okay, gives us an answer of 66.8281. All right. Now, the correct number of significant figures. If they all have decimal spots, what you can do as a little shortcut is count how many decimal spots they have, each number has. So like this one has 3 decimal spots, this one has 4 decimal spots, and this one has 2. And then your answer needs the same number of decimal spots as the smallest number of decimal spots of the numbers going into the problem. So the smallest number is 2. So that means our answer needs 2. So it'll be 1, 2 decimal spots. This is where we're rounding 2. That's the last decimal spot we want. So we look here. 1 past it. Does that round it up? Yes, it does. So our answer becomes 66.83. Okay. So it's a little bit of a shortcut if they all have decimals. Okay. All right. Let's take a look at number 4 is practice. If you want to pause the video and attempt it on your own, that might be a good idea. Okay. So hopefully you have it done. If not, you're just following along. This comes out to be 107.1156. Okay, this one has 1, 2. They all have decimals, so we can do a little trick. So 1, 2, 3, 4. This one has 2. This one has 4. So the smallest number of is 2. So 1, 2. Here, the 5 will round that up, so we get a final answer of 107.12. Okay, so that's the rule for adding and subtracting. Okay, now we have a second rule for multiplying and dividing that's different. The nice thing about this is, for what we do in chemistry, I would say probably 90% of our problems only use multiplying and dividing. And this is easier than the adding and subtracting one. So most of what we're going to do is this. Okay. All right. Excuse me. So similar to the other one, we're going to do the math here. So I'm going to do the math on this. Times 0.2 times 90. We get 0.144. Okay. Now, in the multiplying and dividing rules, you count the number of significant figures for each inexact number or measurement. So again, for what we're doing here, we're assuming all these numbers are measurements. Count the number of significant figures. So here, decimal points, we start from the left. We don't count until we hit a number that's not 0. So no, 1. So this has 1. Here, same thing, decimal, don't count, 1. No decimal, so you count from the right. Again, we don't count until we hit something that's not 0. So no, yes, so just 1. So this is kind of it's not a bad example, but it's not a great example because all of the numbers going into it have the same number of significant figures. We'll show you a different one here in a second. So then round your answer so that it has the same number of significant figures as the smallest number of significant figures from the measurement numbers going into it. The same number of. So the adding and subtracting was rounding to a decimal spot. This is counting number of significant figures. So what's the smallest number of significant figures from our numbers going in? Well, they're all 1, so the smallest number is 1. So we need 1 significant figure. You're always keeping the first ones from the left, no matter if it's a decimal or not, because it doesn't make sense otherwise. So our first significant figure is a 1, so we keep that. We only want 1, so we look here. Does that round it up? No, because it's a 4. So we get final answer of just 0.1, 1 significant figure. Okay. All right, let's look at number 2. Same thing, it'll give us a little better idea. So 5,200 divided by 6.779. Now, as you're going to see on my calculator here, we get a really long decimal. You don't have to write this whole thing out. I would just write out enough of it so you've got enough digits to round to the correct number of digits, basically. So like none of these even have more than 4 numbers. So if I did something like 767.07, that should be enough. Okay. All right. Same thing. Count the number of significant figures for each of these. So no decimal place, so we start from the right. Don't count, start with a 2, so it's 1, 2. 2 significant figures. Decimal point, count from the left, start here at the 6 is the first one that's not a 0, so 1, 2, 3, 4, 4. Right? What's the smallest number of? Well, 2. So we need 2 significant figures. So we're going to keep the first 2. So the 7 and the 6. So we're going to round to the 6. Does the 7 round the 6 up? Yes, it does. Remember, we're just doing normal math rounding. So we want to round 767.07 to the tens spot. So it'll be 770 would be our answer. And that's how you do the multiplying and dividing rule. It's honestly, it's a lot easier. Okay. All right, now, what if we come across some problems where we have to do both adding and subtracting and multiplying and dividing together? And because they have 2 different rules, we have to do a little bit of rounding in the middle. Do the math following the mathematical order of operations rules that you guys already know. So like, parentheses first, multiplying and dividing, then adding and subtracting, like that order. When you hit the point where you would switch from one rule to another, now when we're talking about one rule, we're talking about the significant figure rules, the multiplying and dividing or adding and subtracting. So in other words, when we're doing the problem, when we reach a point where we would have to switch from either adding and subtracting to multiplying and dividing or the other way, then stop and do the significant figure rounding before continuing to do the math for the next math operation rule. Continue doing this till you reach the end of the problem. So let's take a look here. So if we look at this first example, the first thing we would do by math order of operations is parentheses. So that means we would do what's in the parentheses, which is adding first. So I'm going to add those together, 45.7 plus 263.91. Okay, I get 309.61. Okay, so I'm gonna kind of write that above the top here, 309.61. Okay, now what's the next thing we would do according to math order of operations? We would divide. All right, well, significant figures, adding has a different rule than dividing. So I'm going to have to do the significant figures for the adding rule before I divide. Okay, so for the adding rule, remember, these both have decimals, right? So I can do the little shortcut. This has 1 decimal spot, this has 2. So my answer needs 1 decimal spot. So it would be the 6. I look here, does that round it up? No, it does not. So my answer rounded for the adding rule would be 309.6. Okay, now I have more of my problem to complete. Now I divide, so I'm going to do 309.6 divided by 8.05, and I get this. Again, a really long number, so I'm going to put enough of it to get the right number of different figures. Let's see. That should be more than enough. Okay. All right, so we divided. What's our dividing rule, or multiplying and dividing rule? Well, that's count the number of significant figures. So our top thing here has decimals on the left, so 1, 2, 3, 4. Bottom one has 3. It's the smallest number of significant figures, so it would be the 3. So we go 1, 2, 3. That is the one we want to keep, the third one. So we look here, does that round it up? Yes, it does. So our final answer will be 38.5. Okay. Last one. You're almost there. Okay, just another practice one. So order of operations says on this, it would say we do multiplying and dividing first. So we've got a multiplying here in the middle. So I'm going to multiply 15.047 times 0.0288. And I'm just going to rewrite this with that number before. Well, actually, I'll do what I did before. I'll write it above the top here. So this is going to be 0.4333536. I could have cut off a little sooner, but that's fine. All right. What's the next thing we would do? Well, we do the subtracting and the adding. Okay, well, that's a different rule. So we've got to round for the multiplying rule first. So How many significant digits does this number have? That's 5. How many does this one? Decimals, count on the left, don't count. Start with a 2, count everything, 3. So we want the smallest number of, so it's 3. It's going to be 1. We need to keep 3 significant figures. 1, 2, 3 to here. Does that round it up? It does not. So this number, and I'm going to just put it down here now, so I'm going to write the whole thing. So 6.83 minus, and this rounds to 0.433. Well, okay, so we rounded this 0.433. Now I'm just gonna, so plus 5.9. Now here, it's subtraction and addition, so there's only, we can do all the math together and then just round at the end because that's the same rule. So 6.83 minus 0.433 plus 5.9 gives us 12.297. Now, luckily, all of these have decimal places, so we can do the little trick with how many decimal places they have. So this has 2, this has 3, this has 1. So our answer needs the smallest number of them, which is 1. So 1 decimal place would be to the 2. The 9 will round that up. So our final answer will be 12.3. And there we go. And we're finished. So if you guys have questions, you can always text me, message me, email me, whatever you need. The homework for this is the page 10 on the other side of the homework sheet that I had posted yesterday. All right. Good luck.